Hello, students. Miss Roll here with your notes on free body diagrams. So for this set of notes, our learning target is I can draw a free body diagram. So we're going to learn what that is here in just a minute. But first, we're going to review our four main types of forces. So first, you have the applied force, right, which is a push or a pull. Second, we have friction force. This is the opposite of applied, right? It's the force going against any kind of motion. We have the gravity force, right, which is what's pulling us towards Earth, kind of keeping us on the ground. And then we have the normal force, which only occurs when the object is touching the ground or a solid surface. And that normal force is the opposite of gravity. So if gravity is down, normal force would be up. Again, that's just a quick review of our four types of forces. So what are free body diagrams? Free body diagrams show the direction and amount of forces on an object. So direction and amount of forces. These forces are represented in arrows. So in a balanced force situation, all the arrows are the same size. In an unbalanced situation, at least one arrow would be different. So a shorter arrow is a smaller force, and a longer arrow is a bigger force. The long arrow shows the direction of the movement, right? So if one of the arrows is longer, that's showing the direction it's moving. In our picture here, our applied force arrow is longer than any of the others. So that tells us that this object is moving to the right. A reminder, we kind of already talked about arrows, but now we're going to be putting them together and giving them some more specific labels. So to help get your minds around this, we're going to go through a few examples. That's really the best way to do this. So we've got a car here. It's on a motorway, so we can assume the car is moving. And now we've got to draw our arrows. So we have our four main forces: applied, gravity, friction, and normal. And we have our four arrows. So first of all, I like to start with gravity, right? Unless we're talking about something in space, it's going to have gravity. So I'm going to grab our down arrow, put it here on my car, and I'm going to label that one gravity. Now, if you remember of our definition of our four types of forces, the opposite of gravity is the normal force. Normal force, opposite of gravity. It's kind of the thing keeping us from like falling through to the center of the planet or something. So I'm going to take my arrow, put it up, since that's opposite of gravity, and label it normal force. Now, assuming something isn't, falling through the air or isn't like being like pushed up into the air, I guess, normal and gravity are usually going to be the same size, just because they're balancing each other out. So if it's not moving in that direction, they're going to be the same size. Now I've got applied force and friction force. So I know friction is opposite the direction of movement. And if my car is moving to the left here, then that means my friction force is going to be opposite the way it's moving. So that means it's going to be to the right. It's opposite the way it's moving. And then my last arrow is my applied force arrow, which is going to be to the left since that's the way our car is moving. And I'll label it applied force. Now, the last thing I have to do is remember this car is moving, so it's unbalanced forces. That means one of my arrows, at least one, has to be bigger than the others. Okay? So think about it for a second. Which one do you think is going to have to be bigger? It's going to be the applied arrow because that's the direction it's moving. So that one's going to be bigger. So I'm just going to make it longer to show my applied force is bigger. Let's go on to another example. All right, here I have an aircraft. This is plane flying through the air. All right, so we've got our airplane moving through the air. So first of all, we think through these four forces. Remember, they told us normal, if we looked at that definition, normal force only occurs when something is like sitting on a solid surface. Is our plane sitting on a solid surface? No, it's not. So I'm actually just going to delete this one since I know we don't have normal force happening for this plane. Now, again, we're still on Earth, so I've got gravity happening, and that's going to be pulling down. I'm going to go ahead and label that gravity. And now here's where this one gets a little bit trickier, right? So if we look at our plane, we can assume it's moving. So that's going to be, it's moving to the right. So that's going to be an applied force, right? Our applied force is the direction of motion. And I'm going to label that applied force. All right. And then now we know we have motion happening this way. So that means we must have friction, right? Friction is the force opposing motion. And so in that case, it's going to be opposite of our applied. It's going to go that way. Friction force. This will be a fabulous answer on any of our assignments. I will tell you, you might look at this and go, wait, there's no up arrow. So wouldn't gravity just be pulling the plane down? And you're right. What we actually have happening is a second friction force that's counteracting gravity. Okay? And that is that fluid friction, right? Keeping our plane in the air to balance out gravity so it stays up. But you don't have to worry about getting that piece correct. I just wanted to let you know. The last thing is, again, one of our arrows has to be bigger to show our motion. So in that case, I'm going to make my applied arrow way big to show, I'll scoot it back a bit, that our plane is moving to the right. All right, last example. Got a guy pushing on a fridge here. We're going to assume that fridge is not moving, so he can't make it budge. So let's start off with gravity as we usually do. We've got gravity, right, pulling down here. We do have, let's focus on our fridge here. We do have a ground right under the fridge. So we've got a normal force pushing back up, opposite of gravity. And then now we look, the guy's pushing, right? We know a push or a pull is an applied force. So we definitely have this applied force here going that way. And then again, we know that friction, we've always got friction as kind of opposing motion. It's trying to stop things from being in motion. So that's going to be opposite of the direction he's moving, right? He's pushing off to the right. So our friction is going to be the opposite here, and it's going to be to the left. Now, thinking about this one, right? We have nothing moving. So our arrows are going to stay the same size, right? This is a balanced force situation. So the arrows are going to stay the same size. So basically his applied force and the friction of that fridge are equal, which is why he can't get it to move. All right, if you have any questions, please ask somebody in class. But that is it for our video today, and I hope you have a fabulous day.